And next, let's take a look at the second part, interpreting the box chart. Okay, so the one key thing with interpreting the box chart is really to understand what each component of the box chart represents, and the spread or the variability, like how spread out or how condensed the box chart is. So for example, let's say this is 0, this is 10, this is 20, this is 30. So I'm going to draw one box chart. And let's say here. Okay, and then I'm going to draw another one that's like that. So let's say this is A and this is B. Let's say this represents the weight of packaged beef at grocery store for $10, let's say. So now you can see here, interpreting the box charts, we're basically looking at, oh, I missed one thing here. So let's say this one, the median is here. So interpreting the box chart. So first, the keys are, number one, know the components. And I think you're very good at this. So components of box charts. So again, that's the min, lower quartile, median, upper quartile, and max. Again, min, lower quartile, median, upper quartile, max. So if the question is, let's say, which store would you prefer to shop at, store A or store B? Then if we take a look at this, you see that for A, this one here, this is more spread out. So spread out means high variability. So that means that in this case, the weight of the packaged beef varies greatly from unit to unit. One package may be, this is very exaggerated. So one package may weigh, let's say this is 7 pounds, and then the next package may weigh like 11 pounds, right? And then same with the grocery store B. But the better thing with grocery store B is that we can see that this box chart is a lot narrower than that of grocery store A, meaning that there's less variability here for grocery store B, meaning that the weight variability for the packages that you get is small, right? So also another thing is that if we take a look at the absolute values, the median for store A is here, and the median for store B is here, which is higher here. And also, generally, all the numbers, the entire box chart for store B is to the right of that of store A. And you can see the maximum for store B is much bigger than the maximum of store A. So that means that not only is there less variability for store B's product, store B's product generally weighs more than store A, right? So there are two things to notice. So two key pieces of information. To note. The first one, how spread out or narrow is each box chart, right? So spread out means high variability, and narrow means low variability. And also compare the key values. So notably, you're comparing usually the max, the median, and sometimes even the minimum. Okay, so that's how to interpret the box chart. Note two things. Number one, note how spread out or how compressed the box charts are. And number two, compare the key values. So max, who has the bigger max? Who has the bigger median? Who has the bigger minimum even? So in this case, store B has the better maximum, median, and also minimum numbers. They're all higher than store A. So then store B in this case is the good answer. Okay, so instead of narrow here, I'm going to say compressed. So that's everything to do with box charts.